So let me create a new class so that we can start up with the generic option. So let me call it as list sample. So let me remove this static. So everything will be same as we have seen, right, in our non-generic. But the only difference is that you can have a specific restriction on type here, right? So let's open up the program one. So whatever we have done here, let's see whether it works fine or not. So let me copy the same main over here, which is our analyst, right? So here you don't have a specific type of the analyst for generics, rather you have something called list. Let me show you how we can actually define a type which is of generic. Now for generic type, you have to mention your class which you're going to use. Now here you have something called list, same as a list which you have seen in our generic, and then you have to provide a type. Let's say I'm going to provide a type called int, let's say, right, is equal to new list of int, which means this is a int collection and it accepts only int. Now you can see as soon as we create a variable for that collection which accepts only integer, right, then you can see all other objects, whatever you have created for all other objects will give you an error, right? So which means it won't accept any other data types which you have, right? It accepts character because character is a subset of integer, so that's why it accepts character, right? So let's do one thing, let's give only integers. So go to add again, all the methods are same as our list, no change in it, right? So let me give some number here. Right? I've taken few integer numbers, right? And it won't even allow the decimal or bool or anything else, right? So integer and the lower types will be accepted in list. So if you give a long value again, it will accept, but there will be a boxing problem, right? So this is how we normally mention a generic collection items. Now using generic collections itself, you can create a non-generic. Now when I say you can create a non-generic, which means you can actually give data type here as object, list of object. It means it starts taking any object you want, right? So in that way you can actually make use of your list and list of as objects too, right? Which will give you a behavior of your non-generic collection items accepting all object types, right? Fine then. Now here we have seen this, we have fed the data, right? We have populated it and we have added some data, and you can see we are actually getting the count where it will give us the count of total elements you have in list, right? And in order to iterate through the list, right, you have a for loop, right, where you can see I can get my count and I can loop on the for loop, and I've got each value of element here, because this list again is going to save all the elements in an array format internally, right? And you can see I'm using the reverse method and again a for each, because it's a collection item again which accepts int. Now there is a chance that in for each last time I've used object, right? But this time I can use int because I know that the object obj, which is a list class object which is a generic type, right, accepts only int because we are restricting it with int here, right? So basic declaration is the class you are using and the angular bracket, data type and angular bracket. This will give you the generic type of collection. Fine. So this is how we normally define. So let's run this and see how it is working. I can see here the count is 4 and you have all the elements and even the reverse is working. So let's check out the remove one. So you can see obj.remove of specific element which is 211. You have 211 in your STR. Now which means you are trying to remove a specific object, or here in this case you are trying to remove a specific integer value, right, from the object, from the collection item, right? So run this up. You can see 211 and other stuffs which we have added, and we are removing 211 and it got removed, and we got the space freed up and we have removed this, right? So this is your generic collection item. Same way you have remove at, remove range and other things, right, where you have restricted something. Now whenever you try to use any method, right, now take an example of remove itself, obj.remove, right, automatically you can see it is asking for an element of type int. If you remember in our objects class, which is a earliest class, right? So if you have seen this, when you use obj.remove, right? Now you can see it's an object here. Why it's an object? Because it's a non-generic type, and non-generic type collections demands object type, and you can actually feed in any type of object you want. Same way, while reading data also it will actually will give you that yes, it needs only object value. So that's how it's going to work. Right. So we'll also see when we create our own generic class, right? I'll show you the way how we can create our own class objects and the objects of our own generic classes in this way. Okay. So that is about your list you have. Same way, you can actually go ahead and create a queue again, right? And you can continue working on this queue. So let me just take up a new class. Let me call it as queue. Let me call it as generic. Right? So here I'm going to take a queue which will be generated. Let me close this program and list here. Right? Now here I'm going to take static void. So here you have a queue, right? So let me take this queue, code which I've already seen here. Now you can see we have a collection sort generic, right? For all generic collection types, the namespace is the main namespace is collection sort namespace under system namespace directory. Now you have to make it generic. So let's make it something called double. That's it. Right? So here your queue accepts only double value, or the numbers which double can hold. Right? That's the reason why you can see we are getting an error on here. Now here let me make it as add. Sorry. Now we are in queue, right? A queue you can use in queue to feed data, right? Because this is a queue and it follows first in first out, right? First in first out pattern. So we'll now add it as in queue of, let's say I'm going to give it a dot this one. right? By default, we know that if you define any decimal value in .NET, it is by default a double, right? If you want to convert it to float case, you can actually convert by suffixing it with F character, right? So this is your decimal value. Same way you have your enqueue it more and more details, right? Now you have 4 different elements over here. So if you run this, you'll see different peaks. So let me put a debug point here because it's going to fail there. Now you can see here you have peak value, which is 900.98, which is the last value, right? The first value we actually entered, right? And you can see the out which we got is popped, which is dequeued value is 900.98. Same way 213 and got dequeued. Same way 9090 dequeued, and then you have 9.898, which will be peak value, right? Which is 9090 will be next dequeued. So in this way, it will maintain your first in first out pattern. But yes, you have to obey the actual restriction you have made. So while actually defining your methods in queue, right, it will actually show that you have to give only, or you will actually get only double value. Check this out. So let's say I'm using queue. Now you can see when I say in queue, it says you have to provide double item. By default, the generic restriction which you applied for data type will be applied as right. Same way, let's say DQ, right? Check out, DQ is something which will return you a double value, right? You can see removes and returns an object at the beginning of the queue, which means at the beginning of the queue it will return what it will return? It will return a double value. This is DQ. Same way you have your peak. See here, even your peak will actually give you a double value because we are doing all these methods on top of a queue, which have got a restriction on a data type that it should accept only double, and this is registered, right? So that's how it's working, only on double. But yes, it will follow the main principle of first in first out. Right? So this is your queue, which is of generic type. Same way you have stack. So let me add a new class. If we take this stack generic, let me remove this static here. Go back to static for new. Here we have try catch here, and now so we have already seen the stack how it's working, right? So let's take up the stack code. Right, so here I don't have it as generic, so let's go ahead and create it as it. Now you can see even for stack there is a way to accept it in generic, right? So here let me take it as something called string. This time I'm going to take the string, which is stack and bracket start and string. It accepts only strings, not a number, not a decimal, not a character, right? So we have stk.push. Now the push is actually embedding data into a stack memory. So here let's say we have this Now you have 4 different values which you have. Now you can see I'm actually popping more than 4 times, right? So let me remove the remaining pops and peaks so that it won't give any error. Now again here I'm actually having one more peak which will give me an error. Alright, so let's run this and you can see the value. Blue is the one which got added last and the last in first out. You can see the blue got out first. Same way you have MVC added, popped out. You have .NET added second last, popped out, and you have Apple. Right? The values which you have added over here, got popped out, right, based on your last in, first out pattern, which is a behavior of first. Right? So these are few things which you have already seen in our generic collections, non-generic collections, and which we are looking at generic collections. So apart from this, we have few more, right, which are specific only to generic collections, which is like, let's take an example of hash table, and let's see how hash table works. Now, so hash table is a specific type of generic collection item you have, right, where you can give something called key and a value pair of elements. So at a time, whenever you are adding any data, right, you have to add 2 different elements of it. Now your hash table is something like your lookup table. Now I hope you guys know what is lookup table. Let's say you have some table where your roll number or ID is there, right, and you have different details and student name, student academic details, student address, and so on. And there is some other table where there is student roll number and name, right? So if roll number or name is present in some table, I can directly go to there. Now I will use this roll number and name table as a lookup table for the first table. Now first table contains everything, right? So I wanted to look up so that client will not be confused with the huge data. Rather, I will maintain a unique lookup table for employee ID and name, let's say. Right? So that is something which you can actually maintain in hash table. Now here, let's see how we can actually make hash table here. Main of, we have string array. Let's take it as A. Now in hash table, right? Oh, we have taken it as, let me take 1. Right? So you may have hash table. When I say hash table, you have something called hash set to, where you can see a specific type of value is taken. Now let me go to hash table. Fine. So we have seen the hash table one, right? So whatever we discuss now on hash table is something which is of a non-generic type. Fine. So we have non-generic type which saves key and value, right, which is a hash table, right, where you can key or value can be an object. Same way in generic collections you have something called iDictionary. Right, which can save key and value again, but with restriction of key and a value. Now here in hash table you can see, let me show you how it actually takes up. You have add of, you can see it seeks 2 values, 2 objects as such. Now one is a key and second one is an object. Now which is a value, right? One is a key which is of type object, and even your value can be an object. Now here, let me give one as something. Now you can see it will take any key of type object. Let's say 2, let's say some then. Right. So in this way, I can add multiple values. Right. So now, this is something which is feeding hash table with a key and a value pair. Now you can see I can actually get data, right, directly whenever I have something called roll number in this case. Now, what happens if I add a duplicate one? Let's say I'm adding st dot. Now your object, which is your key, should always be unique. Let's say I'm gonna add some 2 again, right? So let me call this run, and then let me call this console dot read key, right? So I'm gonna place a breakpoint over here. Okay, what is the problem? Okay, there are 2 mains. That's fine. So we're gonna remove this thing. Fine, you can see there are already 3. You can see if you want to see during debug time, you can go to the variable. Now you can actually get everything. 1 is SAN, 2 is blend, and 3 is gone. Now this is a debug view which you are looking at during execution of program, right? And then if I try to add new value with the same key, duplicate key, right? Now you can see it will throw you error that it already contains a dictionary item called 2, so it is not allowed, right? So that's the reason why make sure the key is always there. Now how can I make sure that key is there? Now here you have hash table internal methods. Now you can check something called contains key or contains value, right? Now you can have anything you want actually. Now this contains by default will take as key, and if you want to use specific key, you can go ahead and say true, right? If not HT contains, which means if HT doesn't contain any value to, then add this, otherwise don't add, right? Let me put a breakpoint over here and run. Now you can see it will check whether it is there or not. It will be there though, that's right. It will come to the next. Now it won't give me any error, rather it will come out of a program, right? Now let's see how to read the data. Right? This is something which is protecting feeding data in hash table. It's very important to check whether the data is there or not, otherwise it will give you some catastrophic errors here, right? So in order to get data, right, you have, again, your hash table is something which can accept a key, right? Now whenever you use an array, right, now that is giving you a key. So let me just use an loop here, and let's say I want to run till my hash table dot, you have something called count. Count will give you the total number of elements in the hash, right? Now let me trim the elements here, console.write line out. Now here I'm actually looking for key here, which is ht off. Now you can see it requires key, right? So what I can do I plus 1 length, right? Because I start from 0, it goes till the count. So when I do I plus 1, the iteration starts from 0 and value or the index I'm seeking will become 1, and it will go till 1 to 3. Fine. Now let me run this. Now you can see we have SAN, bed and all. Yes, Navya, you are asking something. There is some disturbance in your voice. Fine. So this is how we read data, and we iterate through. Now think that you have few elements like I can give any key, right? In this case, let's say I gave a key called tree, right? Key has to be unique, but I can give any type of key that is not restricted. And let's say I'm going to give some permission, which means I gave something which is not iterable through your indices, because you have to provide your key. Now here you can provide your key actually now, which means I can loop on, but I have to make sure I am iterating through all keys. Now this is the reason why you have a special type of iteratable element in hash table. Now each element, whatever you add, right, is called as a dictionary entry. Right? Each entry is a dictionary entry. One dictionary entry comprises of a key and a value. Right? That's what we say. Now let's see with the for each. Let me comment this out. Let me take for each here. Now for each, I know that this is an object first. Right? Now we used to use this, right? That you have an object and iterate through everything. But instead of object here, we know that in hash table each element we add is a dictionary element. So let's take something called dictionary entry, an item in collection called your HT. Right? So this will take your dictionary entry and it will make sure that I took two places. Fine. So it will make sure that it is iterating through each and every entry here. I can't actually go with a specific type called object. You can go with object, but not like integer, string, or any other thing which you have seen till now, because each entry contains two different values. So when you have that, then your dictionary entry will help you out. Now how can I get the values? Let me take key here. Now you have your item, which is dictionary entry, contains two internal properties called a value. Sorry, a key first. Let's take a key first, which will give you a key, and let's take a value where you have your item dot value. Right? So each dictionary element entry will have its own key and a value. Now you can see here the key is an object, so you have to convert it to string, and a value is to string. Right? And let's print this. Let's say key and give some space and a value. Fine. So we are printing a key and a value over here. Let's run this and see. You can see here you have your key and value 3, 2, 1, and so on. And you have a tree here. Fine. So this is how you can actually iterate through your collection item, which is a hash table, which is of non-generic type. Right. So similarly, if you want to have a generic type of collection item, right, you can go with, let's say, generic. Now you can comment it out and say I dictionary of. Now the adding patterns and everything will be same over here, right? So let's say it's int comma string, now, which means you're actually restricting your values here. The type of values, I would say, the type of values you are actually trying to add. So that is about your generic and non-generic type of collection items. Now, based on the requirement, right, you can choose whatever collection item you're looking for. Here the stack, right, or a queue or an array list if you want to maintain non-generic, or if it is generic you go for list, right? And based on these elements you can actually take up the values. Right? So here there is something which we have to understand as a last step, Now, till now we have seen that in many cases, right, we created a class object by providing some restriction to some type, right, which we normally call, or which we call as a generic class. And generic class requires some type to be defined, which will be used by internally by that generic by that class, right? So similarly, we can also create our own class where you can make it a generic. Let's see how to do that. Let me create a simple class and let me call it as generic sample. Fine. Now here, let me create one more class, just a trigger class, which will have your static void name. Let's say it is. So this is an empty class anyways. So let's see how we can actually define a generic class. Now here, when you have a simple class, right? Now how can I create an object? I can create an object in this way. Just generic obj is equal to that object. Here we don't have any data type restrictions which we are doing. Let's see how to do that. Here, in order to make it generic, you can use an angular bracket and specify that I want to get some type here, right? Now I'm just using T over here in order to make sure to make you in sync with the other types here. Now you can see whenever you go to stack, right, you can see stack of T. T is nothing but any type over here. You can provide any type. It doesn't have to be T, I can take anything. Let's say I'm taking a variable called I. Yeah, take it up. Not a problem. Right? Now how can you use this internally is the question. Now I can define types using this, which means I define normally in some O is equal to 90, right? Same way I can define a value for I. I, let's say I'm taking variable as I some n, right? Which means whatever data type I'm going to pass here, right? That data type will be assigned to all these variables or methods. So let me define a simple method, public. Let's say it is returning I value, right? And let's say it is going to take some get data of, let's say again I want an I type. Now let's say B. Now here you can see whatever value I'm making into E will return. Let's say return of, let's say B. Now this method takes I, right, takes I and returns the data type called I. Fine. Now here this is the types which I have used. Now let's try to create a object for your generic sample. Now you can see until unless you provide some type here, right, it won't allow. Let's say I'm going to provide some int type, right, and I have to create object so that it will take a int. Right, you can see it takes int. Now wherever I have defined I in generic SAM class, everything will become int. Right? See here when I say obj dot n, right? So I have to make it public. Right? So that by default the variable will be your private, right? Now when I take n, right, see here what happens. N is SAM of int, which means it will return you an integer value, right? We have defined n variable with I. If you remember, I is a user defined data type which you are doing, but now it's a sorry. Now it says that it takes only integer as defined, right? So that's how it works. Now the next one is method. Let's see how it works. Method. Now if you go to get data, you can see it takes int value as an argument and returns an int. because we are passing int as a generic type. So that's the reason why it will actually return this. Fine. So let's call some int as 123 here, and let's say I'm just printing it out over here. Right, are we done? Something went wrong. Okay, we already have a main method. You can see that your 123 is working, but we have done this through a generic type of class. Right? So this is how we define generic class. Now you can expand this to any number of preset data types you want. Like let's say I want one more data type to be provided, which means remember hash table, it demands more than one type. Let's say key and a value, right? Let me make it as I and B, right? Which means it will take two different values. So let's say this time what I will do, I'll change this parameter type to B, right, as some value variable, and I'll do one thing, return. Let's say I'm going to define I as some blah blah. Instead of doing that, let's say int h, I'll define, and I'll be assigning L, let's say, but this assigning will take a call, and you'll do h here. Let's see, let me type n here. You are already defining your h right now. Now you can see I have a get data which takes a type B and returns a type I. Let's see how it's working. Now that's the reason why it says a generic type is giving error because type mismatch. Now first I'll take int comma, and do comma, you can see the generic is taking I and B two times. Let me take string here. Right? You have generic int and string. Now here you can see that it normally is int and string. Now it says get data whenever we start typing in get data, right? Let me show you how it's working. See here, your get data returns int because I've taken return type as I, and I is int, and it seeks string value because I'm providing string, right? So let's say I'm taking it as something, right? And I'm gonna assign n value, which is an int value, that is some number, right? And let's say internal to this, I'm printing the value of L of type B. I'm printing type L here, which is whatever data I'm passing, and then whatever I'm returning, I'm printing it over here. Letting have a clear model. Now this is how you create a generic class, and you can expand this to any number of, there is no restriction here. You can expand these types, define types to any number of variables you want to provide. Wherever you want to apply them, you can apply them. Right? So these are something which are generics which we have. Right? Generic classes, how we define. Now you can understand that all the generic collections which you have are using internally their own generic classes by defining or by actually restricting themselves to some type. Until unless user provides a type, it won't allow you to move on. Okay. So this is something which is generic. Right. So any questions till now? So this is about complete collections you have. So you have files and IO streams which you have. So that's what it is. The files is specific to file, which is the physical operations of file will be taken care by files, and IOSIMS is something which takes care of the content. That is about file handling, which we'll be checking out in our next.